Alright, welcome back. So let's just take a quick look at this one. Now, again, I'm asking what values of k will give the quadratic exactly one x-intercept. So to set this one up, um, we have to think about what it would mean for a quadratic to have exactly one x-intercept. Well, for it to have exactly one x-intercept, it would mean a couple things. It means the vertex is on the x-axis. It would also mean that the discriminant, if you're looking at standard form, would have to be equal to 0. Okay, so that's what we're looking for here. We need the discriminant of this equation to be equal to 0. So in the equation that we have right here, a is equal to 12. B is actually going to be equal to negative k. Okay, and C is going to be equal to 27. Now it seems weird to have a b value be a variable like we have here, but again, that's what we're looking for here, is this k value here. So it is the coefficient of x is going to be our b value. So let's try and figure that out. Now, so if we put it in here, b squared is actually going to be negative k squared. Okay, so minus 4 times a, which is 12, c, which is 27. And we need that whole equation to be equal to 0. Okay, so if you look at this equation, the only unknown that we have is k, so we should be able to solve for it. So negative k all squared, just to simplify here, is k squared. And we have 4 times 12 times 27, which gives me 1,296. So we have k squared minus 1,296 is equal to 0. I can solve this equation. I'm going to add 1,296 to both sides, so I get k squared equals 1296. Okay, and then I take the square root of both sides of the equation. So k will be equal to this plus or minus the square root of 1,296, which is 36. So that tells me that there's two possible values of k that will work here. It'll be plus or minus 36. Okay, and you can test that if you want. You can put in positive 36 and negative 36 for k. Find the discriminant for each one should be 0, or you can try each one once you have them and factor them, and you'll see that you wind up with a perfect square trinomial, which means that there's only one x-intercept. Okay, so that's it, that's all. The only thing that's left in this unit after you do the homework here is word problems, which is kind of putting everything together from the year in quadratics into applying it in a whole bunch of brand new situations. So a lot of different types of questions that we weren't able to solve before that now we can. So it'll be pretty interesting once we go through that. But until then, please make sure you're good with these, and then we'll move on from there. All right.